What's going on, guys? My name is Johnny Bandon and I will be your instructor for this CCNA video. This is a video in our CCNA series of videos that's completely free on YouTube. We also have a self-paced and live virtual training course if you click that description below with 1,200 plus practice questions, labs, and access to our team of network professionals and tech professionals to help guide you on your tech journey. Now, with that being said, let's go ahead and get started, because in today's video, we're going to go over AAA. That's Authentication, Authorization, and Accounting. And for the CCNA exam, in the exam objectives as of today's date, which is November 3rd, they just want you to describe Authentication, Authorization, and Accounting. There is going to be no configuration with this, no lab. If you want that, we will be putting out bonus videos as we finish up our course. This will probably be one of them, along with things like ERGRP, RIP, and other basic networking technologies and routing technologies. But in this video, we're just going over AAA at a high level, the concepts, and then we'll break down two of the AAA protocols, Radius and TACX. So with that being said, let me go ahead and hide my face, and let's go ahead and get started. And I'm at the very end of this, so let's go to the beginning. So on the agenda is just going to be a AAA overview, okay? Going over what it provides at a high level, and then breaking down each of these A's, authentication, authorization, and accounting, and then getting into the operations, how it provides us with something called network access control. And then the two protocols, the two main AAA protocols we're going to talk about are TACX and Radius. As far as I'm concerned, I've been a network engineer in a Cisco environment. That's all I've ever used. And then, of course, in conjunction with something called .1x. But that is not technically a AAA protocol. That just provides authentication, and it's typically used in conjunction with Radius. And all these are deployed now and configured with Identity Services Engine. That's Cisco's TACX server, right? It used to be ACS a long time ago, right? We're talking, I think ICE has been out for almost 10 years, maybe even longer now. So if you're ever wondering how to configure this at enterprise level, it's going to be with an ICE server. Typically, when you're labbing up at home, if you want to deploy ICE, it's going to be a big haul. It's really robust, so there is ways to lab this up at home. But for now, just for the CCNA exam, we're just going to go overview of the AAA technology and the protocols. So, of course, it stands for Authentication, Authorization, and Accounting. So AAA provides our networks with secure network access. It has control and enforcement of network access. It also has monitoring capabilities. And then, of course, accountability. It provides us accountability on who was doing what on our network infrastructure and who and what was provided with network access. Okay, so secure network access. So AAA plays a crucial role in providing secure network access to authorized users. And a lot of times, we're not talking about, like, let's say an Active Directory environment. We mean like a user's machine, especially with TACX or even Radius in conjunction with .1x. Through authentication, it verifies the identity of either users or devices attempting to connect to the network. So when we're talking about a switched campus, typically AAA is going to be involved with the secure network access of our Cat5, our wall jacks, right? It could also be used for users trying to SSH to, like, network devices. They're going to be verified and granted access via TACX. And then with the Radius in conjunction with .1x, that we can do something like authenticating actual devices, okay? That's a typical architecture, very simple, very basic architecture of how we use AAA for secure network access. Now, don't get this confused. ADUC uses something called LDAP to provide authentication and authorization to actual users, objects, and resources in a domain enterprise. When we're thinking AAA, think of actual network topologies. Another use case, especially with Radius, is if we ever want to deploy something called WPA2 Enterprise, and that's where in our WLANs, if we want to use a username and password to log in to the Wi-Fi, to get granted access from our computer to the Wi-Fi, typically then we use Radius. And then we have still kind of granting user access, but that's with our Radius server, not our Active Directory server. So please don't get that confused. When I first started learning AAA, this is what always confused me before I actually got hands-on, because I came from a help desk environment where I was used to unlocking user accounts on Active Directory. And then all of a sudden I was told that, hey, you have to get granted TACX access to actually telnet or SSH into our network infrastructure. And I was like, oh, where's the properties on that on the ADUC user? And the network engineer just laughed at me at the time. They said, no, we have to go into our TACX server and create you an account. Nowadays with ICE, a lot of things are integrated now, where we can actually do something called RBAC, role-based access control, with an LDAP sync. So pretty cool. You can have your regular user account in Active Directory, or maybe your admin account, also be integrated into ICE, and then still be granting access via TACX, okay? And the way that works at a high level is, let's say this computer plugs into the switch and it's granting port access, meaning we did a radius connection here along with .1x and verify that this actual device can be granted access to, let's say, a VLAN down here, like VLAN 20. And now that computer can get an IP address, and now the actual computing device can grant it access. And now we log in, we authenticate to Active Directory server with our user account here, and then boom, we're in. And now, let's say as an admin, we want to SSH to this switch here. Let's say this is our distro switch 1. Well, what we could do if our ICE server using TACX is integrated with our Active Directory, we could on our user account here add like a property or permissions that says, hey, they have layer 2 switch access, okay? And then on our ICE server, we can put a policy on there that says, okay, this user is granted access to our switches, and apply this policy to it. And that layer 2 switch policy could be anything. It could be just use show commands, wherever the case may be, okay? So that's kind of high level how this all works together in an enterprise. Control and enforcement. So AAA enables network administrators to enforce granular access control and policies. So kind of just what I was telling you, we can actually do role-based access control or rule-based access control and have enforcement on what a user or a network admin can and can't access and what they can do. So it can be very granular here. This is just some pseudo configuration where we're granting users access to different switches. But we could also say, hey, user 1 is granted access to switch 1, but they can only do show commands. They can only get into global config mode and use, but they can't do any configuration. Something like that, right? Or we can limit what show commands they can do. Maybe we say they can only do show IP interface brief. Or maybe they can only do show interface status. So we can be very granular in our control and enforcement of what users can and get access to and what they're authorized for, okay? So with the granting access, that's saying, hey, this user can SSH this switch. However, they're only authorized to do show commands, okay? And then we have usage monitoring and accountability. So with AAA protocols and like something like TACX and Radius 2, we can do accounting where we can monitor what users are doing on our switches and verify that, hey, that was user 1 that did that show command. Hey, that was user 1 or network admin 2 that shut down that interface. So we can get detailed usage reports and auditing capabilities that's going to help organizations maintain accountability of what's happening on their network infrastructure, and also gives them it gives them the ability to efficiently manage their resources, because we can say, hey, we see that this switch has a lot of connections. We see that it's doing this. Let's go ahead and manage that. Okay, now getting into what these actual terms mean. So, with authentication, this is actually going to verify the identity of a user, okay? So let's say, again, I'm SSHing into this AAA. Actually, let's say I'm SSHing into this switch here, okay? When I send that SSH, and then it brings me up to a user prompt that says, type in your username. If we're using a AAA protocol, when I type in my username Cisco, it's going to send that username. The switch is going to send that username via like a AAA protocol like TACX over to the AAA server. The AAA server is going to look at that username that was typed in and say, okay, yes, that user can be granted access to this switch. They are who they say they are. And then once we do the password, right, we're also prompted for a password. Same thing, using TACX, they're going to send that password to the AAA server. AAA server is going to say, okay, this username Cisco is attached to this password Cisco1. If that is correct, they are authenticated. And then from there, we're going to go into authorization and see what this username and password, this user credential, is allowed to do. So authentication is just verifying you are who you say you are. And that's a simple, again, demonstration or example with credentials, username and password. And typically, if we're using a AAA server, we're using something like TACX, and our switch is using a TACX server for authentication, not anything local, we're going to create those credentials at the AAA server. Now, there's other things we can do with authentication. We can have digital certificates being authenticated. We can have biometrics and tokens as well, okay? Now, authorization. Authorization is going to determine what actions a user can do, what resources they're allowed to access, and the services a user or device is allowed to access as well. It grants or denies permissions based off the user's authenticated identity. So you can kind of see what's going on here. So let me actually bring up a whiteboard here. Let's say we have this user here. We have this switch, and then it's connected to a AAA server. And we have it configured on this switch that says, hey, your line VTY lines are going to be login, authenticate. And then we have a couple lines configured on this switch that says AAA new model. And then I don't know the exact syntax, but it's going to be like something AAA authentication to our TACX server here. TACX. And then we'll have something like TACX server, and then the IP address of that TACX server. Pseudocode, okay? Now, anytime someone tries to SSH on this switch, like this user here, we'll say this is me, john.bandon.adm, my admin account. When I try to do that, this switch is going to look at its configuration. It's going to say, okay, when I'm granting SSH access, I have to send the credentials that are getting put in, the username and password that's going to be prompted for me. I have to send that via the TACX protocol to this server. So it's going to send it to this server. The server is going to have this long list of users that it's going to authenticate. So let's just say my username again is john.bandon.adm, and then my password is Cisco1. Once it authenticates me and it transfers both the username and password over, it's going to say, okay, yes, that is a real user. They typed in their correct password. Now, once they do that, there's going to be another line here that's like AAA authorization TACX server, right? Whatever. We're going to now do our authorization policies and our permissions from our AAA server. So once it authenticates, it's going to say, okay, this user is a part of this role-based access control group. Let's just say it's tier 2 admins. And as a tier 2 admin, I'm granted access only to our layer 2 switches, full control. And then I can also do show commands on routers. And that's something you would do, right? For people that are the network engineers, say a junior network admin, maybe you'd be granted full access to the layer 2 environment and just show commands to maybe the routing, right? Because maybe you got hired to work the layer 2. So that's kind of the chronological order of things. So authorization happens after you've been authenticated. So the AAA server identifies who you say you are. Remember, that back and forth where this AAA server applies that policy to the user that's logged in here is done with a protocol like TACX, okay? Radius can also do this, but just from what I've seen when you deploy, let's say there's an ICE server, TACX is going to be used for like users trying to SSH, and then Radius will be used to actually authenticate the network infrastructure and actual users' computers, the actual workstations, to like a gig port here to be granted access to a VLAN, be part of a subnet, okay? But remember, this whole process of sending back messages like, hey, we need to be authenticated. Okay, cool. Then we need to be authorized. And with TACX, guys, TACX has its own authentication messages that are going to be sent. So they have TACX authentication messages. So if we do the Wireshark capture, you would see TACX authentication messages being sent across when we first try to log in. And then they have their own authorization messages. So then after we get authenticated, then we get sent back and forth TACX authorization messages. And then if we have accounting enabled, that's its own TACX message as well. And with TACX, we can encrypt these messages, okay? Now, how does this differ from something like Radius? With Radius, authentication and authorization are combined, and they only encrypt a password that can be sent to authenticate Radius messages, okay? Whereas the entire packet gets encrypted with TACX, only a password that you could configure gets encrypted with Radius. Now, I definitely just worked beyond my slides, but I just want to give kind of the full breadth here of what's actually happening, okay? Now, accounting. This is going to track the usage and activities of authenticated users. It's going to record information like who's logged in, who's logged out. It should have timestamps with it. So again, it's something you got to think of with the AAA servers. Make sure timing synchronized, okay? What commands were executed? How much resources was a user using on that server, okay? Now, again, going over the two different AAA protocols. First, we have TACX. So, two major ones, TACX and Radius. Key things about TACX. It's Cisco proprietary, and it uses TCP port 49, and it allows the entire packet to be encrypted. And remember, for each of these A's, authentication, authorization, and accounting, they each get their own TACX packet, okay? Oops, didn't mean to do that. And then Radius. Radius is going to be an open source protocol that uses UDP ports 1812 and 1813 to transmit Radius packets. It combines authentication and authorization, but it is extensible. So you can add on to this. You can carry custom information with Radius, and that's why it's usually used in conjunction with .1x as well. Because it's open source, it's a lot more programmability with Radius. Okay, so that's going to be it. That's going to cover our AAA section. I hope you guys enjoyed these videos. Hope it wasn't too confusing without actually getting into configuration and lab time, where you see a user, a switch, and a TACX server all working together, or Radius. Kind of hard to conceptualize. But the whole point of that is AAA provides identity verification with authentication. It provides authorization and permissions, saying what a user can and can't have access to. Then also provides accounting, which means we can log what's going on our devices. We can do auditing and who has executed what commands, who logged in at what time, etc. Okay? Two major protocols we use are TACX and Radius. TACX is going to differentiate between authentication, authorization, and accounting, meaning there's a TACX packet for each A in that AAA. Then we have Radius. Radius is going to combine authentication and authorization to a single packet, and then it can only encrypt the password, where TACX, you can encrypt the entire packet for additional security. TACX is Cisco proprietary, and then Radius is open source, which makes it a little bit more extensible. Okay, so if you enjoyed this video and you're ever interested in coming to our live virtual training or paying for our self-paced training, if you're an active duty soldier, reserve, or National Guard, guess what? It's free for you. You can use Army Ignited in the Army Cool program and use your $4,000 a year to pay for training completely free on the Army's dime. Or if your unit or organization does in-person training, Trepa Technologies trains Army units already in person. We bring all of our computers. We cater food. We bring devices for the classroom like Raspberry Pis, GeoLiNet travel routers, and we have a 90% pass rate. So if you're interested in that or the Army Ignited, click that link in the description below and let's go ahead and get certified. Thank you, and don't forget to like and subscribe.